We are now discussing SQL, a commercial language for defining and manipulating databases, and we have seen the basic query constructs. Among them, we have seen how to join two relations and ask other queries. Among the additional constructs, we have seen the ordering construct, and most importantly, we have seen the aggregate functions. Today, we will see some of the additional constructs which are provided by SQL for modification, views, and data definition. So today's lecture, we will discuss some of the additional SQL constructs, namely the constructs for modification of a database, for definition of views and querying through views, and the simple database definition itself. So we will first discuss modification of the database. A database may be modified in three ways. Firstly, we may insert a new element in some relation of the database. Secondly, we may delete some element, that is some tuple from a relation in the database. And thirdly, we may modify some entry of an element of the database. So now we will see them one by one. First, we will see delete. The simplest query in delete may be delete borrow. It simply means delete all tuples in borrow. This means delete all the tuples in the borrow relation. But we may want to delete only a particular tuple. So we may delete now in this condition, you can give a condition here that from the borrow relation delete those tuples which satisfy this condition. Delete from borrow where card number is equal to F53. That is, it will delete all tuples in borrow such that the card number is F53. But let us try and solve a slightly more complex problem. That is, suppose, why I may want to do it is a different question. Suppose I want to delete in the borrow relation, I want to delete the entries of all books which are borrowed by Vijay. That is, in the borrow relation, I want to delete entries of books which are borrowed by Vijay. Now this is slightly complex because I will say delete borrow where. Now how will I get Vijay? That is the difficulty. We will use the SQL style of set operation. Delete in the relation borrow where the card number is in where. Now here you can give an SQL statement. It will return a relation which is a pure SQL statement. Now we have to find out the card number of Vijay here. That's all. So this statement can be written as select card number from user where B name so delete borrow where card number is in select from card number, select card number from user. So we've got all the card numbers, and in the borrow relation, if the card number matches this, we will delete. So this way now, using this in clause, we can start deleting many things. Let us say we will delete all books corresponding to Vijay provided his date of issue is some 15/7/95. That is, we want to delete entries of books from borrow for books issued by Vijay on 15/7/95. Here it was sufficient to take out card number, but now we will have to delete out as well as not only card number but also date of issue. This is not difficult, this is fairly simple. And card number in. So this is from the previous idea which we employed. Using that idea, we can directly write down this query. A slightly more complicated version of the same query is Actually, we do not have a relation in which we do not have two relations which have got two attributes in common in our example. In our example, all the relations have got only one attribute in common. Suppose we had two attributes in common, then the problem we could have framed a slightly different problem. So we'll take a different example, not our library database. Let us say we have a relation R which has got attributes A, B and C and D. And let us take a relation S which has got attributes A, B and P. Now we want to remove from S those tuples who have such that the A and B values are available in R. See, in our example here which we had was, in the relation borrow, we found out the card number is in the relation R. From the relation R, we found out the card number of Vijay. Okay. Now, we want to remove from S those tuples such that C is equal to X and D is equal to Y. That is, from S we want to remove those tuples such that the AB values in R corresponding, the C and D values in R corresponding to those AB values are X and Y. To write that query, delete S where this is how. Previously, wherever we use the in clause, we got out a relation having only one, returning only one attribute. We can do it to return more than one attributes as well, as we see in this example. This takes out the A and B attributes corresponding to C equal to X and D equal to Y, and this deletes those such that this AB in this must be in this set only. Next we come to the insert operation. The insert function the book relation has got three attributes: accession number, year of publication and title. So when we write insert into book, we have to give it in that particular order. The function is insert into R. The keywords are insert and into R, and the keyword is values. You have to give this value, and the third value corresponding to the three attributes. And if you do not remember the ordering of the attributes, but you remember the ordering of the attributes, you remember the attributes themselves, you can still write out the query in a different form. And you can change the ordering of, you can write down explicitly the attributes that you want to use. Now you have given the order in this, the attributes in this order. It is different from the attributes, the order of the attributes mentioned here. And now you will write them down in that order. So you will have insert into book, then you will write down the attributes, and then you will write down the values, and they will correspond to the attributes in the order in which you have given them. Now suppose you don't write down one of the attributes. This book has got 5 attributes, and you suddenly write down insert year of publication, title, and you write down the values. Then in the database, normally you should not do this. This is not what is normal. This is not what is there in the normal definition of a set. But if you do that, then in the book relation, there are 3 attributes. One is accession number, the other is year of publication, and the third is title. And if you do not mention all the attributes, suppose you mention only accession number and title. So you have just mentioned here accession number and title, and you did not mention this. So you wrote insert into book title comma accession number values, and you wrote this. Then here will be database, etc. And this will be called what is called null. This is a special symbol saying that there is nothing here. This field is absent. It is called a null field. In fact, you may specifically write down null also. These languages provide that you can write down null null for that field. Normally this should not happen, but it may happen because you may not have all the information during updation, and if you have no information and you still want to update, so some maybe later on you may fill up that field. So these languages provide you the facility of using null. So normally till now whatever we have assumed is that all the attributes must have values. There is a special value called null which may be there, and this null means that there is no value which is present here. You may even check, you may do select, once you use null in your query language, you may have things like this. Null is a keyword. So it will list out those accession numbers where this field is null. Next we come to the updation. Update is change of value. Now update can be always achieved by a combination of insert and delete. Any update operation can always be achieved by first deleting and then inserting. So these two combined will give you the update operation. You want to change some value, you delete that tuple and you rewrite that tuple with that value different. So you delete and insert, you will get an updation. But SQL does provide you with some features for updation, and it provides you what is called an update construct. Update borrow, that is update the relation borrow, and what do? You set date of issue is equal to 19/8/96, where update the borrow relation, and when you update that borrow relation, you change the value of the attribute date of issue and make it 19/8/96, where accession number is 57839. So now using this update you can realize that you can do it not only for each individual tuple, you can do it for a whole set of tuples. You can just add this value here. You can just change the value, you can modify the value. Let us see another example. Update the sub relation and set price equal to price into 0.95. So it gives you a where S name is allied and price is greater than 1000. So in all the tuples in sub where S name is equal to allied and price is greater than 1000, the price will be modified to price star 95. That is, it will be reduced by 5%. That is, allied says that okay, after it has supplied the books and the books have been entered, there is a negotiation, and after that negotiation it is agreed that these all books worth such that each of the book is worth more than 1000 rupees, there will be a 5% discount. Then the database has to be updated, and this updation routine, if executed on the database, will give the 5% discount and reflect it on the price of that person. So this is an assignment statement actually. This statement is an assignment statement. Till now we have not really done a single assignment statement. All the operations that we have done are extracting information, doing insertion or deletion, but updation requires assignment, and this set operation is the assignment statement. So we've got three operations: insert, delete and update, by which we can modify the database. Next we come to the concept of a view. Now what is a view? As I had mentioned that in the library database I may have many people using the library database. Now those who are borrowers of books need not know the suppliers who has supplied what book. In fact, you just need not even know all the details of all the users. And a particular information which is conveyed to all the borrowers may be, you may want to know the titles of all the books, the year of publication and their accession number. So the book relation is available to you. And you may want to know which user has issued which book. So you may want to know the relationship between this book, title of the book, the accession number of the book, issued by which person. You need not know the card number, just the name of the person and the address of the person. That's all. You may want information related to the library and information related to borrowed. That is, you want to know those books which have been issued, what is the title, the accession number, the name of the person who has issued the book and the address of the person who has issued the book. That's enough. And I need not provide you with any other information. Whereas the library management department may want to have information regarding when he issued the book, how long he is retaining the book. That information will be conveyed to another person who may not have other information regarding suppliers. Whereas the accounts department or the accession department or the acquisition department will have all the information regarding the suppliers but need not know who has borrowed which book. So being a huge database, there will be different people using this database, and for each person will be given what is called a view of the database, and that view will tell that database that this is the database as far as you are concerned. So you will be giving a logical dimension to the database. Your own concept of the database will be provided to the person, and the authorization and the accession will be depending on whatever is provided for that particular user or user group. For that, all languages provide the concept of views, and the construct for views is called create view. This will create a logical relation. It will not create any physical relation. Create view V as, and you give a query expression. That is, you will write create view V. Now this is the new logical name to this expression. This is the new logical name to this expression. Whenever this name is used, this expression will be evaluated. This relation will not exist explicitly in the database. It will be computed as and when required. There are methods relating to efficiency which partially computes this relation. The last computation is kept, but let us first understand what is the concept of a view. Create view books 1995. So I want to create a view of the title and the accession number only of the books which are published in 1995. So the books which are published in 1995, the query expression of them will be select title, accession number from book where year of publication is 1995, and I say create view books 1995 as, and I give that query expression. And I say that this is the book 1995 is a logical relation which is a view. It does not exist as a physical relation. It actually exists as a query expression only. Whenever required, whenever I refer to books 1995, this expression will be evaluated. So how do I use this? I can use it in this form. After having defined this, I can now write down any query assuming that this is a relation. So I can So I will use it as a relation. Now this relation will not permanently be there. This relation will be a logical expression as this. So whenever I want this, this expression will be evaluated and I will get it. So whoever is provided with different types of views related to a database, these views will be created and the users will be given their own views, and they will operate on these views assuming that these are relations themselves. Suppose I want to have a view corresponding to the names of the suppliers and the titles supplied by them. So this view I will get. So I must have a query expression corresponding to the names of suppliers and that. So that is simple. We have done a lot of query expressions. We'll have to do a natural join between the sup relation and the book relation, and just select out the supplier name and the title of the book. To do the natural join, accession number is the common key. I'm sorry, it is sup.accession number is equal to book.accession number. So this is the query expression which will create the suppliers and the titles supplied by them. And what I will have to do is I will create a view and give it a name. Create view st as, and then I will give this query expression. Now I may want to concern myself with all the titles. So whenever I have queries, I have decomposed my relations in a particular way because I have defined my database in a particular way. But I may be using certain expressions which lead to relations very frequently. I will define them as views also. But there is a question of efficiency because every time this expression may need to be calculated. So when designing and implementing a database, we may have to consider how we will tackle the evaluation of views in an efficient manner. That we will see later on. But before that, there are some problems of updating through views, and that is important. Let us go back to this ST. We have created a view with supplier name and title, okay, and this we have given it to the acquisition to some department which says this is your view this is your view for the books. You fill up all the new titles and the suppliers who have supplied the titles. This is the information, and suppose you want to update through this. That is, you want to insert a new tuple based on this view. So if by chance I write insert into ST values insert into ST values narrow sign database technology. Now ST has got S name and title, so I have put these two, but this ST actually does not exist. So now where will it insert? Now this, one of these attributes has come from book, and another has come, sorry, this one has come from sup, and this one has come from book. Now if I put this in sup, then I will have, for the other fields in sup, I will have to put null values. And if I put this in database, then for the other fields I will put null values. Now if I put, now this leads to a lot of complications. Updating through views which are combined out of more than one operation leads to a lot of complications and is never allowed in most standard databases. You are not allowed to update through views. You are allowed to update through views only in some special cases. You are allowed to update through views provided the views were created only from a single relation. If the view was created from a single relation, then in some cases you are allowed to update from views, because subsequent queries and modifications of the database may be handled. But if you are updating from views which are created out of more than one such relations, then they may create a lot of other problems relating to integrity constraints. Therefore, updation through views is normally not allowed. Querying through views is very standard and is usually always allowed. Finally, we come to the question of database definition.
Isn't that like read only, write only to use?
Yes, views, you are saying read only or write only. Views is usually query only. That is, you can only query the database. You need not update. That is what I said. Problems of updating. Insert, delete and find. Because views only give you partial information of the database, and only in restricted cases do you allow to update through views, and those cases are normally the case where the view is constructed out of a single relation. Otherwise, there is a lot of theoretical difficulties in updating through views. Having seen everything regarding the database, we come to the lastly we come to the first thing, that is the definition of a database. The definition of the database comes after you have done your ER diagram modeling and you have defined your database. So you have to just define your relations, and to define your relations you have to define them in a relational database as tables. So for that you have got the create table construct. Create table book, and the attributes will be year of publication and the type. Let us assume that we have got a date type which is always available. Then we have got title, which will be of type character 50, and we have got accession number, which will be of type, say, character 10. Say, this is how you define the book. The attribute, the type of the attribute, the attribute, the type of the attribute, attribute, the type of the attribute. So for all the tables you create these tables, and in the middle of your operation, if you want to remove a table, then you write down, suppose you want to remove this table, then you will write drop table book. This will destroy the table. There is a difference between this and there is a difference between these two. The difference between these two is that This will delete all the tuples but retain the structure. It will retain an empty relation. This will not only destroy all the tuples, it will destroy the structure itself. That relation will not exist. Here the relation will exist, but the relation will be empty. And here the relation itself will be destroyed. And you have got other constructs like alter table, in which you may be able to change some of these attributes. But these are the two basic definitions which will allow us to define a database. But that is not all which a database language provides. A database language does not merely provide you facilities for data definition and data manipulation. It provides you several other things. One of them is use of a database manipulation embedded in a programming language. So it will give you how the mechanism in which you can write down SQL in an embedded C code. So these features will be provided by most vendors who provide you a language like SQL. And the additional features which are required for any database, the other features which will be available in any database language are specification of integrity constraints. You will specify what are the primary keys, what are the secondary keys, what are the constraints which must hold during any operation on the database. Second is authorization. Who can do what? Who can? This is not only views, but this is the read, write, and update operations. Indexing. How will this table be stored finally in the disk? That will also be specified so that you can compile it. You may want to store this table sorted in a particular way. How will you store it? You may do it statically, you may do it dynamically. So facilities for storing these tables in a particular data structure in the disk, which is called indexing mechanism. And finally, we have what are called transactions control. That is, these operations which update on a database will be defined in as a set of transactions, and how during concurrent operations of transactions, how to define a transaction, how concurrency will be controlled, and the problems of concurrency will be avoided in transaction definitions. Facilities for doing all of them are also provided in any standard language like SQL. Till now we have not done any of the theoretical foundations or the methods by which we specify integrity constraints and the transactions protocol, the recovery, the file handling mechanism. So once we do them, we will see side by side how a language like SQL provides facilities for doing this. So we will finish our brief overview of SQL here, and we will discuss these constructs as and when we come to the situations. Next day we will discuss integrity constraints.